The United Kingdom Virtual Microscope for Earth Sciences, or UKVM, was funded by JISC. The aim of this project is to create a freely accessible online resource with supporting learning materials. The UKVM is delivered via an internet browser using a system developed by the Open University. It can be used for informal browsing or for teaching mineral and rock identification skills in higher education institutions and schools. The project will broaden access to key, rare and sometimes unique specimens of United Kingdom rocks and fossils in museums, including the Sedgwick Museum in Cambridge and the Hunterian Museum in Glasgow, university teaching collections from the Open University and from Durham University, and rocks from the British Geological Survey. The Virtual Microscope website is a series of rock collections, and it invites you to explore them. You can explore them in terms of place by looking at a map and clicking on different places where we got the rocks from. You can explore them in time. There's a timeline that sets each rock and its formation time. You can explore them in focus, and that allows you to search the whole database for any kind of rock, any place, including the moon. Open Science Lab has presented us with a fantastic addition to the Virtual Microscope project. Not only have we been able to take advantage of the Open University's teaching delivery methods to place materials on the Open Learn site, we're also now involved in developing an exciting new suite of online educational tools, including remote access to laboratories and observatories where students can control instruments and even a telescope to make real scientific measurements. The Open Science Lab is developing remote access fieldwork and also an online virtual field investigation. The lab is also extending the iSpot tool for citizen science to several countries. 2 JISC-funded virtual microscopes have become involved in the project, one for histology and histopathology, and the one we're involved in for earth sciences.
The first thing that we do is to take our hand specimens, which are rock samples like this, and we use a series of diamond-tipped saws and grinding wheels to cut slices and then to polish a flat surface on the chip of rock. Those chips of rock are then mounted onto a glass slide, and the glass slide is then finished by hand with a highly qualified technician who grinds them down to 30 microns. That's the standard size for geological thin sections, and at that thickness you can see through the mineral grains when you use a microscope. We've got 2 different digitizing processors to turn this information into a website form. We have a microscope which has a motorized XYZ stage which will allow us to take large area mosaics of each thin section, and automatically all the photographs that are photographed with that microscope are stitched into a giant mosaic. That's the first part of the process. The second part of the process is to show minerals in rotation, because certain optical properties are only observed during rotation. So we have a second microscope with homemade software. We use a Lego robot to drive it, and it takes a series of 72 photographs as the microscope stage is rotated, and that gives us our rotation optical properties in rotation.
2 specific projects in which we're involved are the Shared Representations and Enquire. Shared Representations is a new innovation in virtual microscopy. We're hoping to allow students to be able to share visions so that more than one student can look at a microscope at the same time. It's akin to standing around a microscope and discussing something that you can see. The Enquire system is an inquiry-led learning system which allows students to create a project using virtual microscope slides. The demo version that we've been involved with uses moon rocks and allows school children to study moon rocks, make measurements of them, and it's something they would never be able to do without the virtual microscope. Let's look at one of the featured rocks. Scroll down. This one's abandoned manganese ore. You can see in an individual rock page it opens up with a whole series of information and images. There's a gallery of different images of the rock and a large image, a hero image of the main sample. In the middle here is a fact sheet. It tells you about where the rock came from, a bit about it and a bit about the thin section. It also has a link to the geological map so you can see it in context. Here we've opened up a virtual microscope and you can see, I'm just zooming in here, you can see the structures in the rock, and in fact you can also rotate hotspots. Here's a pyrite grain with some strain fringes around it, and you can see on the right hand side how those crystals change colour. There are lots of other features of the microscope, and there are rotating 3D hand specimens. Why not get started now? Go to this website and explore the rocks of the United Kingdom.